set theory is a very important topic in mathematics, and in order to adequately deal with this topic, I will arrange series of lessons, but for today we'll be dealing with lesson 1, and lesson 1 will basically be concerned with the definitions of set and membership and cardinality of set. Okay, and so my name is J Aquidouble, and I just urge you to keep track on our activities on this channel, because we are going to deal with this topic in a very simple manner, and we will take our time as we progress along. All right, so let us begin. By definition, set is an organized and well-defined collection of objects. A set is usually enclosed into a pair of braces and is named with a capital letter. Look, there are two things that we really look at. We see organized, well-defined, so that collection must be organized, and not only organized but also well-defined. So let's see some of those organized and well-defined sets. So A, we say A equals 2, 4, 6, 8, 3 dots, 40. And the 3 dots indicate continuity. So like here, 8, and the next number we see is 40. So the 3 dots indicate all of those members of these sets that are between 8 and 40. But how do I identify those members? So we look at the beginning part of the set. The sequence of arrangement at the beginning, you have 2, 4, 6, 8. That tells you that these numbers are even numbers. So it means that order continues in between 8 and 40. So we will say that after 8, the next even number is 10. So it means the next number is 10. The next one is 12. The next one is 14. So continuing until you get to 40. So all of those numbers in between here are the ones represented by the 3 dots. And the reason for this is there are times the members of the set are so many that you won't be able to list all of them, and if you want to list all of them, this bowl will be very small for you. So we use 3 dots to indicate that in between here we have some members of the set. So those 3 dots will be representing those members. So we say A equals, this is the pair of braces. We told you that a cell must be organized, well-defined, and a set is usually enclosed into a pair of braces. The pair of braces. So you will usually see this pair of braces enclosing a set. Then sets are named with capital letters. You will see capital letters. You will not see a small a as the name of a set. It will usually be a capital letter. Okay, so let's see. B equals set of all SDA grade 10 students. C, all players of Lone Star's current team. Okay, so like we said, There are some expressions, I will call them, that resemble set, but they are actually not set because they don't follow the organized and well-defined rules. Okay, so let us look at some of those. D equals all smart grade 10 SDA students. It really looks like a set, but let us see as to whether it is well defined. All smart grade 10 SDA students. Now, this was smart. Smart is a relative term. So if you use a relative term in describing the collection of that so-called set, then it becomes a problem. So for relative terms describing the collection, it makes it not to be a set. Because let's take, for instance, if we have a student in this class called Joe, all right, and Joe is a very good student in math. He scores marks above 80, 90, and 100%, usually. And then, but Joe scored very low marks in physics, for example. Maybe his grades are in 10, 20, 30 marks. So relative to math, he will be considered to be a smart student. But relative to physics, he will be considered not to be a smart student. So smart makes it to be a relative. We won't consider this to be a set. Okay, so let's see. E. The best players of Lone Star's current team. The best players. Best is relative. Okay, so it makes this to be a confusing. So this cannot be a set. There's a way that you can make this a set. If you define what you call best, let's say for example, you could say that best in this case is the first of 5 students or 5 players that arrive on training ground, are the best players. Okay, so that is well defined. So meaning the first 5 players that arrive on the training ground, they can be identified by anyone. You can take someone from Japan, from China, and you bring them and they can identify that, oh yes, these are the players. Once they are identifiable, so it means it makes it well defined. Okay, so that sets a criteria for best. So that would be a set. But if it is just used, openly used, the best players of Lone Star's current team will not be considered to be a set. Okay, F. The beautiful female freshman students. Beautiful. What do you call beautiful? So this is not a set. Okay, now let us look at the membership and cardinality. So we'll look at membership first, then later we talk about the cardinality. A member of a set is any distinct element of that set. I would love you to look at distinct. All right, any distinct element of that set. The symbol E means element of, or member of, or belongs to. So this symbol means either of these. Element of, member of, belongs to is the same thing. And this symbol means not an element of, or is not a member of, or does not belongs to. Okay, so that is this symbol. We will always see these symbols coming into play when we're talking about our set membership. Okay, note, in a set, no member appears more than once. That's where we talk about distinct. Okay, so you will now have in one set you have 2, then you also have 2, then you have 10, appearing. No, you won't see a particular member appearing more than once. Every member will appear only once in a set. All right, so let us keep that in mind as we making progress. Okay, so for examples, if A equals a set of 2, 5, 7, 9, 55, and B is 1, 2, 3, 4, all right, then 1, 2 is a member of B. All right, so let's see. We're talking about the membership of a set. So the membership of a set actually talks about the individual identity, individual members of that identical set. So let's see, in this set A, we have 3, 5, 7, 9, with dots in between here, 55. So like we said, the dots represent the numbers. The order of numbering here is, these are odd numbers. So all of the odd numbers between 9 and 55 are the one represented by the dot. And then here we have 1, 2, 3, 4, with no other number appearing. So here now, this indicates to us that it is continuous. It has no end. It's going. The first one, it continues from 9 until it ends to 50 or to 55. But for this, there is no end. So it means it continues all the way. It continues all the way. Now what the 3 dots here represents. Okay. So for number 1, 2 is a member of B. So what is set B? Set B is this, and we have 2 here. So it means 2 is a member of set B. Is that correct? Yes. Okay, so the next one we have number 2. We have 2 is not a member of set A. Let's see. Set A, we have 3, 5. So we have odd numbers here. So 2 is not in set A. So we say 2 is not a member of set A, which is also, correct. Then 3, 55 is a member of set A. 55 is a member of set A. That's also true. Then we also have 55 is a member of B. Here, is 55 here a member of B? Yes, of course, because we said this set is a set begin from 1, 1, 2, 3, 4, and continuing. So when you see the order of arrangement, it tells you that it's all whole numbers from 1 going to infinitive, no end. So it means 55 is part of that. So it means 55 is a member of this set. So that is also a true statement. Okay? All right. So let's see, the next thing is cardinality. The cardinality of a set is the number of members of that set. It is written as, some can see it and say absolute value, but this is not absolute value, it's cardinality. When it comes to set, it's cardinality. And the cardinality is the number of members. The number of members, how many members in a set. So the cardinality is not about the individual members, the identity of the individual membership. No, the cardinality is talking about the total number of members of that identical set. So we should understand this. That's the difference between cardinality and membership. Membership has to do with the identity of these members, and cardinality has to do with the collection of them. How many are there in the set? All right. So let's see examples. If A equals this, B equals this, and C is this set. Okay, the cardinality of set A, B, and C. All right. So what would be the cardinality of set A, B, and C. Let's see set A. We have 3, 5, 7, 9, and we have dots in between. It should actually be 3 dots, and 55. So there are other members in between 9 and 55 that are also part of this set. So in order to know how many members here, you need to include them. And those members are, let's just list them and see. So how many are they? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So the cardinality of this set is 27. So the cardinality is actually the number of members of that set. So when we see set B, 2, 4, 6, 8, this is 4. The cardinality is 4 members. Then set C, the cardinality 1, 2, 3, 4, ... Hi, this one means it continues without end. So this is infinitive. So the cardinality is also infinitive. So since this is an infinite set, because it does not have an end, so the cardinality will also be infinitive. Okay, it means it doesn't have an end. So we say the cardinality of set C is infinitive.